Welcome everyone to this 2024 seasonal update webinar for the Northern Region presented by the Australian Fungicide Resistance Extension Network, also known as AFREN. I'm Bridget Penner from Ag Communicators, and in today's session we're pleased to have some of the leading experts in cereal disease management in the Northern Region here to present to you. So first up we have Dr. Noel Knight, who is a Senior Research Fellow at the Centre for Crop Health at the University of Southern Queensland. We'll then hand over to Brad Baxter, a research officer in cereal pathology at the New South Wales Department of Primary Industries and Regional Development based in Wagga. And last but not least, a face who's familiar to all of you, I'm sure, Dr. Steve Simpfendorfer, cereal plant pathologist with New South Wales DPIRD based in Tamworth. So AFREN is a GRDC supported initiative that provides up-to-date resources and information directly to Australian growers, agronomists and advisors. You can find a whole suite of resources, including previous webinars, podcasts, fact sheets, the Fungicide Resistance Management Guide, workshops, and more at afren.com.au. So before we kick off, if you have any questions during today's session, please drop them into the Q&A box on your screen. We will endeavour to answer these at the end of the session. But for now, I will hand over to Noel. Thanks, Noel.
Right, thank you. So I'm Noel Knight. I'm a Senior Research Fellow at the Centre for Crop Health, and I'll start the session off by introducing some of the concepts around fungicide resistance and management to try and reduce the risk of that emerging and what that means in our systems, as well as an update around Queensland. So we just had an overview on the Australian Fungicide Resistance Extension Network, and it's a group of experts from different institutions across the country delivering information across the regions on fungicide resistance and a range of resources that I do recommend having a look at if you're interested in more information. So we really, I think, start with the question, why do we use fungicides? And the goal should be to protect the yield potential of crops, which means limiting the impact of disease on yields. And this means that we're having disease control, not elimination. Elimination isn't a realistic goal. And we're looking at applying fungicides ideally when there's a higher risk of severe disease. And we could base that off what we know about background inoculum levels, the susceptibility of the crop you've planted for the disease that you think is a risk in your area, and the environmental conditions. But with this application of fungicides, resistance can and is emerging. And resistance is a reduction in sensitivity of a fungus to a specific fungicide. This is something that's part of the genetics within these different fungal pathogens, which means it can be inherited from one parent to the progeny as they're reproducing and causing disease. So it becomes potentially more prevalent in the pathogen population and that disease across a field. The resistance can also cross between different groups within a mode of action. So it might be two types of group 3 fungicides could both be affected by resistance. So it's important to keep that in mind. And fungicides, if there is a resistance present, they can have reduced ability to control disease. And there's a spectrum where you might have a fairly minor reduction in your control levels, which may not be a big problem in your fields, but that can range up to field failure, which is the worst case scenario. And that's really what we want to try to avoid and keep it to only a minor impact if we can. And if you can't control the disease, it means you have a risk of yield loss because of that fungicide resistance. And that's really the big problem. And you can form your level of risk by how much you're relying on a fungicide to control your disease of interest. If you have a high reliance on just that fungicide controlling disease, that is something where if resistance is developing can become a bigger issue. So we talk about how fungicide resistance emerges. So if we start with a population, maybe it's of a disease that may have never encountered a fungicide. In blue, we have these sensitive types. They'll be killed by the fungicide, but there's one individual that is resistant to the fungicide. So when we apply that chemical, it will reduce the sensitive fungus, killing most of those. The resistant type will survive. And then over time, potentially with other applications of the fungicide, particularly the same fungicide, the resistant type becomes the most dominant in that population. And that means if you apply that same mode of action or that same fungicide, you may not continue to have control. And that's something that we're learning more and more now about ways to try to limit the risk of this emergence. And we'll talk about those strategies through this initial introduction. But there is a path to fungicide resistance that we're all on. So it means that every fungicide application selects for resistant fungi or resistant diseases. That's just part of how it works. But diseases differ in their risk for resistance development, and fungicides also differ in their risk for resistance development. So it's important to keep that in mind if we're talking about different fungicides, how to apply them strategically. And one of the big questions we still have, but is a really important one, is once resistance is here, can we reverse that in a population of that disease? Can we get rid of it and go back to a situation where we don't have resistance? And we don't have the best answers for that yet, but that's why we're talking about this, because we want to try to limit the emergence rather than have to figure out how to get rid of it once it's become more prevalent in our regions. There is some fungicide resistance terminology I'll just run through. This is a bit more sciencey, so forgive me, but I think it's important to understand. When we use the term sensitive, it means that the fungal targets are killed by the fungicide at a recommended label rate. Sometimes reduced sensitive is a term that's used. That's where fungi can persist or survive at low fungicide rates. This may be a reduction in your product performance. You might notice that in the field as more or less disease, and you may end up needing maximum label rates to get the control that you require. And then we move into the resistant category where the fungi are surviving at maximum fungicide rates. So your fungicide, when it's applied, is then failing to provide the control of the pathogen that you want at those maximum label rates. So these can be reduced sensitive resistant, could be termed as decreased sensitivity, depending on what you're reading, but we try to break them into these different categories. And we also have lab detection. So this can be based on actually growing these fungi in a lab on fungicide to determine that they survive. Once we've done that, frequently we can link that to a change in the DNA. And we can, instead of trying to grow fungi, it can take a while, we can go straight to that genetic change, potentially looking at mixtures to try and determine what's present within a field. So fungicide resistance has been described in most of or all the Australian states across a range of diseases, wheat and barley powdery mildew, barley net form and spot form of net blotch in particular, and septoria, as well as black leg canola and some other diseases, chickpea, lentil and mung bean diseases. So important to know what crop you're working with and see what is present. We do also have an image just going back to the resistant, reduced sensitive and sensitive types. We can see on this plate, so it's something the fungus can grow on. At the top where it's sensitive, this fungicide is in this plate. That is not looking white and fluffy. That means the fungus isn't growing. Think about fungi growing on some old bread. Here it doesn't grow because of the fungicide. Here you can see a bit of white fluffiness. It can survive reasonably with fungicide. And here it's looking very happy and growing. It's resistant. That's what we're worried about in the field as emerging as a more frequent part of that population. So what are the main risk factors for the emergence of fungicide resistance? Well, pretty much it's if you have more disease, you have more of the pathogen, which means you have a greater chance of fungicide resistance because more pathogen means greater variation in their DNA, which can occur randomly, but you can have more to select for when you apply fungicides. So the risk of resistance emergence is greatest when the pathogen reproduces quickly, when it's highly virulent, so causes a lot of disease. If you use one single mode of action of a fungicide repeatedly, that's one of the best pathways to get resistance. And if you have a susceptible variety that you need to rely on that fungicide to control disease, that's giving more of an opportunity to select for those resistant types to survive. And we have some recommendations around fungicide management and how to think about it. And it goes back to your basic disease control principles. Variety selection is the foundation. If you can plant the least susceptible variety for your disease that you might be worried about, that's going to reduce the infection potential. It's going to reduce your need to rely on chemicals to control the disease. Integrated disease management is then an important part that should be in the system where you're controlling your stubble, reducing the inoculum in the field for pathogens, rotating between crops, managing sowing times and green bridges. And that's all aimed at reducing the pathogens in that environment. And then if there's a stage where you think disease risk is high based on environment, based on maybe inoculum that had stayed there, fungicides are being considered. And that's a recommendation around only applying when necessary and being strategic. And this can look like rotating between and within your modes of action. When there's mixtures available, they're being highly recommended to try and disrupt that selection process. But it is still important to stay within label rates. And this, at the endpoint of fungicides, is looking to reduce the populations on the plant and stop them from proliferating. And I use this as an example. I hope it makes a bit of sense. But if we think about how cricket is used in terms of bowling strategies, we don't just stick with 2 right arm medium paces to try and control batsmen. We change. We have left arm, right arm. We have spin. We have my favorite with the leg spin, googlies, and changes in what they can have. So I think about it in the strategy that you would use. You would rotate between bowlers to try and disrupt the batsman, which you want to try to limit their ability to proliferate in terms of runs in this case, or disease, what we're talking about. So I hope that's just a little grab that fits in my mind as a reasonable analogy, but something to try and work with if you're trying to develop a strategy. But in terms of more defined fungicide management tips, it's trying to only spray if it's necessary. Limiting your applications means you're limiting the selection pressure. There's a less chance of resistance to emerge. And that means when you do apply a fungicide and you need to rely on it to be effective, there's a greater chance it will be. Choosing mixtures with different modes of actions when they're available, that can be a great way. So you don't just rely on one type, you're disrupting that selection process. Aiming to never apply the same group 3 fungicide twice in a row, alternating sprays between different types, even within a mode of action, so different group 3s can provide some benefit. For group 7s and 11 fungicides, which can be seed dressings and foliar, try not to use them more than once per season in any crop rotation. And that does mean not just considering what you're applying to the leaves, what you're applying to the seed is also having a selection pressure. So that needs to be considered within that rotation of fungicides. Aiming to use fungicides before white infection. So if you can have a smaller population of that disease that's out there, if you can try to control it early before you get more variants that are out there, gives a better chance to be effective. Don't compromise the effective control and stay within label rates, which is an important thing to consider for multiple reasons, not just fungicide resistance. And monitoring your fungicide effectiveness. Are you getting the control that you're expecting based on the conditions that you've been seeing, whether your host background or the environment where those crops are growing? And there are some opportunities to test your samples if it's an issue that you think is leading towards fungicide resistance as the explanation for more disease than you might be expecting. And monitoring is important because we can't really say for sure if fungicide resistance is a cause of a more severe epidemic without characterizing the fungi causing that disease. And that can be, as I described earlier, phenotyping, where we grow the fungus on fungicides to see if it survives, or linking that gene to a genotype or a change in a DNA, which we know then allows that fungus to grow. Once we know that information, we can lead to more informative tests, potentially faster tests, to monitor those DNA changes, not just in small amounts of leaves, but bigger amounts of leaves across multiple fields, to figure out what is present within a field. But we're now moving beyond just saying that you have fungicide resistance. I think where the power starts to come in is we can now say how much you have. We can move towards a frequency if you have 20% of a population or 70% of a population. And that's important for understanding where your situation is at and what level of control you might have, or whether you have an issue that might be there moving forward. We try to summarize these ideas into the fungicide resistance 5, which is highlighting the avoiding susceptible crop varieties, rotating crops. That means using your time or distance to reduce disease carryover, reduce inoculum in those environments, trying to use non-chemical control methods to reduce the disease pressure, And again, spraying only if necessary and strategically, leading into our rotation and mixtures of fungicides and modes of action. So we're not just relying on one type and trying to reduce the selection pressure through one of those chemicals alone. So as I said, there's a lot of information available through AFREN for particular regions in Australia in general. So I do recommend having a look at that if you want more information. And also Centre for Crop and Disease Management has some potential to do testing. So get in touch with the group there so they can see if they can give you some assistance. A few codes here, QR codes that you might be able to scan later on if you wish to get access. There's a guide that's really nice and some other information. So I'm just will clarify then that the once per season recommendation for fungicide applications doesn't include, for group 7s, doesn't include group 7 seed dressings without foliar activity. And there's can be more discussion around that at the end if there's questions. I'll just lead into a bit of the situation in Queensland at the moment in terms of what's been described in the literature. For mung bean powdery mildew and wheat powdery mildew, some resistance have been described for group 3 and group 11 fungicides. Wheat leaf rust, barley powdery mildew, barley leaf rust have had reports of group 3 fungicide resistance, and barley net blotch has resistance described for group 3, 7s and 11s for Queensland at the moment. Now, that doesn't mean that they're at a risk of having reduced disease control, but these have been reported within the region, and there's more information and more testing needed to be done to confirm how much of a risk that is, but something to be aware of. So I'll summarise a couple of small studies that were done for surveying. So wheat powdery mildew in 2022, group 3 and group 11 resistance was detected in fields across southeast Queensland. And we have an indication here with these orange and blues across the region. So group 3 resistance was in all the fields. Group 11 resistance was in 5 of the 6 fields. But again, we were moving with this test. So this was Stephen Simpfendorfer and group at Centre for Crop and Disease Management working together for this information. But they went into the frequencies as well, not just the presence, but then how much in these populations. So for group 3s, you can see it was 100% in multiple fields, or above 80 for multiple fields. That's a fairly high percentage to think about gaining confident control. Group 11 resistance got to around 50%, but was generally less than that. So it's important as a baseline to know where this was at in 2022, probably a more severe season, but what could be there in the future. I was able to do a small study on barley net blotch in 2022 as well, where 10 barley fields were sampled. In this case, we took 60 lesions from across about a 300 square metre area of each field, and we looked at doing the genotyping or quantifying DNA markers. So this is an idea of the transects that we took through the fields in the bottom left. We start with this process by determining which of the net blotches were present and their estimated severity across these 10 fields. So we see that net form net blotch in this green colour was the most dominant pathogen, with spot form present in nearly all the fields, but at a lower frequency. So within those populations, we then determined the frequency of the fungicide resistance, particularly in this case for group 3 and group 7 fungicides. This is a simple colour coding to indicate basically the location of field samplings that occurred from just west of Toowoomba out towards Condamine. You can see across each of those more sampled regions, we had a random cutoff value of 10% indicated that there was fungicide resistance in each of those locations. And frequently it was just for the group 3 fungicides. But we had some fields where it was low as well. So it's important to keep an eye on maybe what's happening in those fields compared to others. We then also moved into the frequencies within each of those fields. So for group 3 in orange, it was sort of around that 20 to 30%, up to around 70%. And group 7's a bit less. We weren't expecting as much group 7 based on what's getting used, And we also had the first report only about a month ago of group 11 resistance being detected in a couple of these fields. And a couple of interesting features. Field 6 was cultivar Getty, which has improved resistance to net blotch. And this was challenging to find a lesion in this field, which is probably a combination of that field management as well as the resistance in the host. So that was important and good to see. Field 8 was more of a fodder crop, so no fungicides getting used for multiple years, but we still had presence of group 3 fungicide resistance. And fields 7 and 10 were the same field sampled with a fungicide application in between, about a month apart, but we can see that increase in the frequency of that resistance and the emergence of detectable levels of group 11 in particular. So it's important really that we start to understand if this is a true impact of that fungicide application and what can we start to measure and learn more from there. But it is something that's in the region at some reasonably high levels that should be kept an eye on. So just a easy summary of these. For group 3 fungicides, 8 out of the 10 fields had decreased sensitivity. If we look at a total region, it was 34% of that population had decreased sensitivity. For the group 7s, it was 6 out of 10 fields and 6% of that population. So quite a bit less than the group 3s, but still present. And for group 11s, it was 2 of the 10 fields, so 5% of that population had decreased sensitivity, so this was only otherwise reported in South Australia at this time, in the same year, in the same season. So it'd be interesting to know where else in the country this is happening and what its impact might be. But the key message is that fungicide resistance is present in Queensland, and it means that we are promoting that variety selection and inocular management is critical to try to reduce that emergence so it doesn't become too frequent within the populations. And when fungicides need to get used, it's that the strategies are strategic, only when necessary, and trying to include those mixed modes of action. And there's potential for testing to inform that decision-making rather than just rotating based on just pick A, then B, then C. If you know what's there, you might be able to be more informed in that strategy of application and fungicide choice. So I will acknowledge the fungicide resistance group from the Centre for Crop and Disease Management, my colleagues at the Centre for Crop Health at the University of Southern Queensland, and the agronomists and growers who gave me access to fields for the net blotch sampling in Queensland. And I think always when agronomists and growers are working with researchers, it's an absolutely critical piece of this type of information and extension possibility. And again, please get in touch with people at AFREN for further information. I think that will do me. I think questions will be at the end, but I will pass on to Brad.
Thanks, Noel. Okay, so I'm just going to give a bit of a seasonal update, primarily focusing on New South Wales. We're just going to have a look at, I guess, the different diseases, primarily in wheat, where we have fungicide resistance, the climatic conditions that we've experienced this year, and then just go through a little bit of management moving forward based on the time point in this season. So, firstly, we won't dwell on this one too long, as most people here would be well familiar with these diseases. Here we've got stripe rust, leaf rust, powdery mildew, yellow leaf spot, and Septoria trudicide blotch. Septoria trudicide blotch will be one that I'm focusing on primarily in a few slides' time. But as we can see, they all have varied, I guess, environmental conditions that they'll respond to in regards to temperature and leaf wetness period. So within our major wheat diseases here in New South Wales, we have fungicide resistance detected in leaf rust and powdery mildew and Septoria trudicide blotch. GRDC and DPIRD co-investment, we, myself in the south and Steve Simpfendorfer in the north, run a at no cost for grower and advisor plant diagnostic and management service. So what we have here is just a tableized summary of the inquiries we've received from 2019 through to September 1st, 2024. And what we can see is, and I'm not going to dwell on this one too much because I know this is the major point in Steve's component of his presentation. But we can see in the top 10, we have stripe rust. So this is for this year. These are ranked as in the number of inquiries up until the 1st of September. So we've got stripe rust has been the most inquired, then crown rot, septoria, and yellow leaf spot. But in the others that make up the top 10 are all environmental, nutritional, and herbicide issues. So those have been submitted as disease, but obviously have turned out not to be, and Steve will discuss that further. So environmental conditions for this year in New South Wales. So it's sort of been a tale of two tapes. Here is growing season rainfall from the 1st of May up until the 31st of August. The central west and the north of the state have had a minimum of above average to highest on record type scenarios for their rainfall, their in-season rainfall. Hence why the disease pressure has been much higher in the north than in the south. So we can see that particularly the southeast, Wagga down through sort of that much higher rainfall flowing through Albury and Henty have particularly been quite dry. And when we talk about disease progression, there are three very key months, being August, September, and October. And this is where, you know, these necrotrophic diseases such as septoria come from the lower to mid canopy and get up onto your flag leaf where they can cause the most damage. But what we can see here, this is the August rainfall. So the first of the three key months. So we can see that a lot of the central west is you know, about average, but a lot of the south, which is the stronghold of septoria in particular, has been very well basically below average. So this is starting to put the brakes on our disease progression, particularly when we talk about septoria, as opposed to stripe rust, which will be slowing down, but has a lower leaf wetness requirement and still may be a consideration here in the south with susceptible varieties. So now we're going to move on to septoria itself. And here we can see in the top picture, we have septoria, which is characterised by the black pycnidial structures existing in the lesion, as not to be confused with yellow leaf spot that does not have black pycnidial structures existing within the lesion. And a bit of, I guess, biology, they're both wind dispersed. They have different wind dispersal distances, and they also have second, so primarily the first is via ascospores, which comes off stubble. Secondary is the conidia, which is either for septoria splash dispersed or wind dispersed short distances for yellow leaf spot. They have very different latency periods, with septoria being much longer than yellow leaf spot. And they have very different risk profiles when it comes to fungicide resistance or insensitivities. So for a disease epidemic to occur, we need, firstly, you know, the environmental conditions, which, you know, when we talk about risk factors across the state, have differed north to south, but we need the environment, we need the pathogen, and we need a susceptible host. So over the last 5 years, we've been running a statewide paddock survey where it's random. We deal with agronomists and growers. We gain access to their paddocks, collect samples, and then assess them visually and via qPCR for presence of different pathogens. So here presented is the Zymoseptoria triticide, which is the causal pathogen of Septoria triticide blotch. So we can see coming out of a very tough 2017 and 2018, the levels were quite low. We can see that in the top left corner there. And as we move across to 2020, we start to see it build through 21 and probably peaking in 2022. We saw a slight decline on the back of a very dry year in the north last year and a tough September in the south. So we do have levels of the pathogen existing within our farming systems. Now, the other componentry to all this is having a susceptible host. So here is just the resistance ratings from the 2023 disease screening for Septoria. We can see that a lot of our varieties, these are predominantly the spring varieties, sit in that moderately susceptible to susceptible or worse category. Left unchecked, we can that is a yield limiting. So what varieties or we have that actually exist in that MRMS or MS type are generally long season red wheats, so which may not be suitable for all environments. So bringing that all together, this is a graph from 2022 and 2023 growing seasons at Wagga. So what we can do is pull this together where we talk about having a susceptible host, which we have each year when we talk about growing our wheat varieties, our major spring wheats. We know we've got the inoculum levels, and we know from work done here at Wagga that Septoria can exist and survive on stubble for a minimum of 2 years. So that really high Septoria year of 2022 still gives us a risk factor for the epidemic development. However, when we have a look at the 2022 rainfall versus the 2023 rainfall here at Wagga and the differences in the epidemic, we can see that there's a few factors here that really explain why 2022 was more severe, and that we can have high inoculum levels, we can have a susceptible host, but like 2023, when we don't get the right environmental conditions, we don't see those epidemics, and we can use that in to exploit the pathogen and to, I guess, reconcile the needs for fungicide applications based on its biology. So we can see that the 3 months that we had in 2022 and 2023, the growing season, the rainfall totals were very different. So in September 2023, we had 4 mils of rain here at Wagga. This really curbed the epidemic. The temperatures were also quite different, where we can see that the 2023 average temperature was much higher, which dried the canopy out much quicker. So this is sort of what we're seeing again so far this season. We've had, in the south, we've had lower than average rainfall for August 2024. We haven't had a rainfall event in the south here since probably around the 26th of August, and nothing on the forecast for the next 10 days or so. So when we don't have these type of repeated and prolonged rainfall events, which I'll show you in a second, this can really limit the ability of Septoria to get out of that lower canopy up onto the flag -1, where we're going to do yield damage. So this is the number of rainfall events that lasted greater than 2 days in duration. So we can see how conducive 2022 was as opposed to 2023. The point I want to make out of this is that I did some checking this morning in regards to a number of locations across central and southern New South Wales. And the reason why I've excluded the northern New South Wales is because it's not primarily a Septoria region, is that we're tracking much like 2023. So 2024 is not 2022 when it comes to Septoria, and we have to keep that in mind when we're making our spray decisions. Now, fungicide resistance. So over the last few years, and we're doing this again this year, we've been sending leaf samples away to AFREN and his team at CCDM to do the fungicide insensitivity testing. And this is just a visual map of where the samples have come from in regards to 2022 and 2023. We can see that the bright pink dot and the maroon coloured dot is the presence of the CYP51G1 mutation. So this is predominant across our landscapes. So what this particular mutation does is confers the highest level of reduced sensitivity to our triazole, so our group 3 fungicides. So each of our actives are compromised to some extent, more than others, when we talk about the presence of the CYP51G1 mutation. And when it comes to fungicide selection for septoria control, this becomes important. And we're going to touch on this in a second. And what does this mean for us? So STB in crop management, and appreciating that the audience is probably quite varied in their geographical locations, and that the growth stages that typically we target septoria at have probably passed in that central to northern area, or for other fungicide applications for other pathogens. So this is primarily going to be based on the central west through to the south, where probably our GS39 sprays are done or still being considered. So we need to understand, as we've gone through, that we can have a susceptible host, we can have high inoculum levels, but if we don't get the correct environmental conditions for septoria to develop, then the epidemic will not progress through. Keeping that in mind, we need to, get in our thought process that each fungicide application is a potential resistance selection event, which Noel explained quite clearly earlier on in the presentation. Do not apply fungicides if they are not required, and correct identification is primary to that. Now, across, I would guess most of the cropping belt in New South Wales, most would have received a growth stage 31-32 fungicide application, which has curbed the septoria epidemic to this point, combined with environmental conditions, primarily here in the south. We're coming up now, or being done already, our growth stage 39 sprays. Do we need them if we haven't pulled the trigger on them? And this is quite an individualised, decision when it comes to your enterprise or to your growers' enterprises. But there are some general, rules that we can use. We've got some pretty decent STB growth curves or disease progression curves based at work here at Wagga over 4 years. I haven't presented them due to time restrictions, but we know pretty well how STB will act under a variety of scenarios with varieties with different resistance ratings. What we would say at this point in time is if you don't have 20 to 30% septoria infection in your lower canopy, given the outlook that we're now faced with over the next 10 days of warmer temperatures and no rainfall on the horizon, that these sprays may be able to be reconciled. And by reconciled, I mean hold off and then potentially pull them if they're not needed. The reason being, in southern New South Wales, the last infection event that we had, as I think I mentioned earlier, was at around the 26th of August. We're past the curative component of any fungicide for that septoria infection, and we won't see the expression of that until the end of this month. So what that means is, in the event of any significant rainfall with none on the horizon until the middle of September, that septoria will come out and express. But we start to flower around that first week of October here at Wagga, and that moves, forward or backwards depending on where you're located. But what that means is, in the event of any repeated rainfall events within that time, the risk for septoria is pretty quickly reducing, because once we start filling grain, the risk of yield loss starts to decline rapidly. And given the biology of septoria, if we're not going to get an infection event until the middle of September, we're not going to see the expression of that until middle of October, which is partway through our grain fill. The messages that I would like to convey for New South Wales is through the work that Fran's done from the samples that have been submitted. Strobilurins are still effective. That mutation has not been found in New South Wales. Although we do have, due to the CYP51 mutation, varied efficacy. And what I would express here is that if you're specifically targeting septoria, epoxiconazole or prothioconazole are still quite effective at field rates, whereas a lot of the earlier generation fungicides are not. Always rotate, rotate modes of action, actives, and different used mixtures, adhere to label rates, and seek help if you suspect spray failure. Now, finally, before I hand over to Steve, I just quickly want to touch on this as an awareness. Last year, barley samples were sent to Fran and his team, and these are a couple of new points on the resistance map based off those samples. So reduced sensitivity to group 3s in barley spot form and barley net form, as well to group 7s. The other one is also to group 3s. So, Fran, correct me if I'm wrong, but these are still classed as lab detections, but it is something that we would be very interested in if you perceive a spray failure. So that is enough from me. I will now hand over to Steve. Thank you.
Thank you all. So I'm going to hit some pretty key messages pretty quick to get us through this. So the pyramid we saw before, what's the most effective way not to get fungicide resistance in a pathogen population? Don't apply fungicides. Simple. Okay? And the problem is we're putting a lot of fungicides on because we're not getting the diagnosis right first. Okay? So the critical point when you get to that stage is make sure you're diagnosing the right thing. Brad presented a bit of this in a table form, but yeah, 571 direct inquiry samples so far across New South Wales into Victoria and Queensland. What's the most common disease we've seen in 2024? It's actually misdiagnosis. 23% of what we've dealt with is nothing to do with disease at all. It's environmental, herbicide injury, nutrition, nutrient deficiencies, it's other things. But people wanting to put fungicides on for those. I know it's a bit of a shock to people, but fungicides do not correct frost damage and they do not correct nutrient deficiencies. Okay, so what's been going on? So early on, we had a lot of white circular spots in cereal crops. It tend to be white like that on the left-hand side in our wheat and tend to have a brown margin in barley. This is due to droplet freeze. So the droplets sat on the leaf, they froze overnight, and how much damage they did was really as to how quick they thawed in the morning. So the one on this leaf on the right-hand side in the first photo, it thawed quicker and didn't cause as much damage. The other thing we saw, particularly in the longer season varieties, so Illabo and Kitty Hawk, is when we got our first run of frost, we got this yellow tipping, showed up really suddenly, just related to frost. But people thought it's yellow, it's got to be stripe rust, I'm spraying a fungicide. We see it every year also in barley, tends to be particularly Spartacus, where you get these yellow tipping towards the leaf on the two right-hand photos, and you get these little brown spots in behind. This is just physiological spotting, a stress reaction within barley, okay? The giveaway here is if it was net blotch, it comes from the base of the plant. So you should have lesions on your lowest leaves and not just on two mid leaves. and not towards the tips. Pathogens don't concentrate to leaf tips. Getting on specific leaves and the new leaves come out, don't get frosted. That's just a timestamp of when your cold conditions occurred, okay? But a lot of fungicide went out. I've been talking to agronomists. I would hate to actually add up how much fungicide went out for frost tipping in Illabo and Kitty Hawk wheat this season. It is astronomical. Okay, the other thing, we are having some issues with transient micronutrient deficiency. So on the left here, particularly in radar, we're seeing this interveinal yellowing, which we think is just transient zinc deficiency. So, you know, root systems being wet for early on, not really exploring the soil. They just run out of that nutrient and suddenly spot up. So yeah, just think about what other things are going on. The other thing we're starting to see a lot of as well is can be a genetic link, side effects of some of these. So leaf tip necrosis on the left there, related to carrying a particular gene combination, a leaf rust gene LR34 and YR18. It's particularly prevalent in radar. So we're seeing radar as up in north here. As we go into some hotter conditions, it's tipping out the flag leaf and you get that death of the tip. And everyone goes, it's got to be disease. I've got to put a fungicide on, okay? This is just a physiological side effect of having that gene combination. It will happen irrespective of whether there's any rust in the crop at all, so fungicide will not stop it. Nice picture here. Certainly the LR34 gene causes more leaf tip necrosis. We do have LR46 in a number of our varieties, which does do it, but not to the same extent. And you can see compared to the Avocet or the other variety, that's what happens if you don't have those particular leaf rust genes. Yep, you don't get the tipping, but you get smashed with leaf rust. So it's just a side effect. I don't think we'll see much of the last one, particularly we see it in Sunmax, melanism, where we get the browning of the glooms. That's really related to warm, humid conditions during that heading phase. You get overproduction of a pigment called melanin, and you get that brown pigmentation. But yeah, that's very seasonal dependent. So think about if it's only happening in set varieties, shows up suddenly, you know, either contact Brad or myself, we can look up the genes and we can actually let you know what it is. So much cheaper than putting a couple of tens of $1,000s of fungicide across a paddock for no reason. Brad went through this one. I use this in a different way. So I think if everyone could just learn some very, very basic plant pathology, we'd save making a heap of mistakes. So we've got our optimum temperature ranges there for each of the diseases. So let's look at stripe rust, 12 to 20. That's when it's going quickest. You actually look at when you get to above 22 degrees, the stripe rust fungus becomes dormant in leaves. Doesn't mean it dies. It means once you get over 22 during the day, usually, it just won't cycle and it doesn't keep going until you come into cooler conditions overnight. So what you do is you go on an extended period. The number of calls I'm getting out of Queensland where they've had over 10 days of either high 20s or into the 30s and want to spray for stripe rust just does my head in. Like you can see I haven't got much hair. It's all been pulled out. Okay, we've got the leaf wetness, which you talked about as well, and then what we call the latent period we need to know about. So this is the time from when a spore lands on a leaf, you either see pustules with the rust, or you start to see some lesions with the necrotose, the yellow spot and the septoria. Okay, why these numbers are actually important is they drive two things. They can help in a lot of ways. So if you actually look at it, oh, sorry, I'll just make a point. I think Brad hit this. The number of calls also about septoria in Queensland, northern New South Wales. We don't get it up here, guys. It's just yellow spot. Okay, but why you need to know the latent period, because all your fungicides, when they've got curative activity, so mainly your triazoles, they basically take out half the cycle time. So your curative activity phase is not restoring green leaf hair. It's when you've got an infection in the latent period in the leaf and how far the fungicide can go back in the infection cycle until still take it out. And it's roughly half the cycle time. So if you look at stripe rust, it's on a 10-day cycle on a susceptible, 14 days in something with some level of resistance. So it goes slower with resistance. If you put a fungicide on, you've basically got curative activity about 5 to 7 days. So infections that happened 5 to 7 days ago, you can put a fungicide on, you won't strip any leaf, you won't lose green leaf hair, and you won't have any further pustules come out. If you're actually beyond that, there's enough resources in the infection to complete its cycle. You'll strip leaf, cause leaf damage, and you can still have pustules come out. Okay, and why that's also important is, you know, look at yellow spot, which is our dominant, when we do have actually disease in the north, yellow spot is our main one this year, particularly on 2022 stubble, because the spores on the stubble that cause the problem, they need moisture to mature, and they've reached that on 2022 stubble. They haven't done it from 23 stubble because it's too dry. But when you look at yellow spot, it's got a really quick cycle time, 4 to 7 days. So your curative activity on your fungicides is only 2 to 3.5 days. So in terms of spraying in front or behind rain events, very different proposition based on the cycle time with yellow spot compares to stripe rust. Yellow spot, you've really got to be in front of it if you want to stop that infection event of a rain front coming through. Whereas stripe rust, you can let it come through, and as long as you get on within 5 to 7 days pushing it a bit, you'll take out that infection, won't get any new infections. The other reason it's really important is it can be really helpful in stopping misdiagnosis up until our flag leaves fully emerge, okay? So in those earlier stages, because what you've got is a temperature, your rate of leaf emergence is linked to temperature. So 105-degree days is the critical temperature, so that's your max min added together, divided by 2. You need to accumulate 105 days worth of that to get each new leaf come out. So in theory, that means each leaf is roughly coming out every 10 days. So something like Septoria, it cannot be, it's got a long latent period. It's got a 28 days, so it cannot be on the top 2 leaves. So if you send me a picture or ring me up and say, I'll get Septoria, and I ask you what leaves are on, you say the top 2, it biologically cannot be Septoria. It cannot cycle that quick. You're outside it. And certainly stripe rust, it can't be on the top leaf, and probably, pushing can't be on the top 2 leaves. So that should have been the logic that should have been applied when we saw all this frosting happen, in our kitty hawk and our Illabo when we got our first run of frost. It was all on the top leaves. They just tipped out with a reaction to frost. Everyone sprayed it because they thought it was rust. Okay, it cannot be rust. It can't be on the top 2 leaves at that growth stage. So my key message, 2024 is not 2022, okay? We all saw so much disease in 22, we couldn't put enough fungicide on. It was just so conducive, but it's not the same this year. The problem was we come into this year with a prediction of a La Nina from the Bureau of Meteorology. We won't get into politics of that, but if anyone's still sitting there think that we're in a La Nina year, particularly when, what's going on in the north, you need to go and recalibrate your decisions, okay? Still a lot of people are saying to me, I'm putting it on, I remember 22. Forget 22, it is not 22. Okay, Brad looked at this. So this is the first 6 months. Yes, it was a lot wetter in 22 than in 24. But the other big difference in terms of stripe rust is when rust first showed up. So in 2022, we had a really early epidemic, first detection around Temora on the 20th of May. This year, it's not until the 29th of June around Griffith. So it's actually 40 days later is our first detection on the east coast of stripe rust in 2024. Now, the earliness of the epidemic is really linked to how severe it is. So that 40-day delay has a massive implication for how much disease we're actually going to get. Okay, the other thing that's really different is the temperature. So the optimum temperature for rust cycling where it's cool is these ones in green. And you can see in 2022 where we look at that September, November, it just wouldn't warm up. Extended up into this, northern, even into Queensland, we're in conditions where the rust just kept cycling. Whereas even in 2023, you can see how that dropped down and we weren't as conducive with temperatures. So it wasn't so much that 2022 was wet, it was that 2022 was also cool and mild, and it just kept cycling. It slows the rate of you moving through growth stages in wheat varieties, but it also was very conducive to rust. So our epidemic this year is going to be driven by our spring, and I can tell you up here, it's over for rust. It is just too warm. When you're hitting high 20s, 30s, it's your rust is cycling slower. You move through your growth stages quicker, so you're getting to more resistant growth stages. Your APR, adult plant resistance expression, is a lot stronger with heat. Plus, your spores don't survive as long. They actually die because they desiccate and dry, and with warm, windy weather, those spores just dry out very quickly and not viable. You can see this again, Brad put these up, just looking at 22 versus 23 even, that change in temperature, moisture, the levels we found in plants in 22 was through the roof, big drop up in 23. And when we do the sampling over the next couple of months in 24, we expect we're going to be even lower this year. So adult plant resistance. So this is, again, we're not just more about using fungicides properly. So a lot of stuff goes on with stripe rust. It's probably our main target. What we're using with stripe rust is adult plant resistance, and it's a beautiful mechanism in that rust is a biotroph. It needs living cells to survive. Adult plant resistance is programmed cell death, kills the cells where it senses the stripe rust fungus is in it, the surrounding cells, and you effectively kill the infection. You can see that with the death in behind these orange pustules on the left-hand side, and actually stripping out leaf. Now, the issue with this is if adult plant resistance kicks in a variety, and I'll go through when it kicks in one of my final slides, then you actually strip a heap of green leaf, taking out established infections. And it's often what we're seeing this year. That's when your hotspot of stripe rust actually becomes obvious in a paddock. It's because APR's kicked in, stripped out where that infection's been ticking over at low levels. You haven't found it in your scouting because there's only the odd hotspot in the paddock, so it's hard to see, and you strip that green leaf out. The other key point I want to make too is the spores, those pustules, the spores don't disappear overnight. So people see this, picture on the left-hand side. I've got to spray it, my rust has gone crazy. You've got APR behind it. Fresh infections are yellow and the spores are fluffy. They dry. As they dry and desiccate, they become orange and they flatten out. So when you look at that, those are weeks old when you're getting orange flat pustules like that. They're from old infections. They're not new infections. And now your adult plant resistance is protecting it. So if you go to the edge of a hotspot, hold up a flag leaf next to the hotspot, you'll see all this flecking in the leaf. And that's the adult plant resistance taking out spores that are trying to infect the leaf from the hotspot. Walk 10 metres away from that further out into the clean crop, hold up another leaf, you'll see heaps less flecking because it's challenged by fewer spores. That's how you know APR is working. Applying fungicides after your genetics has already taken care of it just doesn't make sense. Trust the genetics. So what we've got to do, bud, is we've got to calibrate our fungicide strategy to match the resistance in our varieties. This is the most complicated slide I got. So the thing with rust is what we're dealing with stripe rust is we're starting off from being very susceptible. So every variety is susceptible as it comes out of the ground, and it moves to resistance as it goes through its growth stages, as it ages. Okay, and it reaches there at different stages based on its resistance. So MR variety, something like Hellfire, its adult plant resistance will look after it from somewhere from GS30 to GS32. An MRMS variety, so Sunmaster, will be from GS37 to GS39, full flag leaf emergence is 39. Then something that's an MS variety, it's not going to do it until Ornpeak, 49, or through to Heading, and Scepter, which is an S variety, is not going to do it till much later. So you haven't got that helping you out. So what we need to do is overlap our fungicide strategy to actually when that APR is going to kick in, so we don't let the APR take out infections. The other thing to remember is there's a huge interaction with nitrogen nutrition. So not a heap of high-end paddocks this year, but when we have a high-end paddocks, it delays expression of our adult plant resistance genes, and really you have to manage it one level lower. So can it make a variety such as Hellfire MR behave more like an MRMS, so it just delays it, or a Sunmaster, which is MRS, behave like an MS variety? So just factor that in. So what we're doing is trying to overlap. So this is why flutriafol, on starter fertiliser, is so effective. It'll generally take it and stop all that early infection and get us through to around GS30, 32. So in an MR variety, you won't be seeing any rust at all. And it's really going to take the pressures off MRMSs. But it's all about actually, overlapping. And a lot of people talk about putting their fungicide in with their herbicide, and it really depends on the growth stage where you're doing that. So down south, it tends to be more mid-tilling, around GS25. Your leaves aren't protected if they're not out. So fungicide only protects the leaves that are there when you spray. So the new leaves that emerge are unprotected. And you've got this big gap about, well, when do you come back in so that you're not letting the APR take out infections? Whereas the further north you move, we're inherently, because our crops move quicker, our herbicide sprays are going on closer to GS30. So that's why it works in something like, our MR varieties, or even to some extent our MRSs. We're taking it out there. There's not time for build up for when the APR kicks in. So really important to understand how that's working. If you get a head around that, you're doing it. But the real key consideration now is, what variety you actually growing? What's its resistance level? So when its APR is going to kick in. What's the, adjust it for what the end levels are, and what growth stage yet. So in the north, where we're really growing, Lancer is our dominant variety, and nothing's worse than MRMS. We're already in Heading. Rust is over. Our APR doesn't get weaker over time. It gets stronger and stronger. So we've got to match that to our management. So, put the spray rigs away. The other thing too is there is no evidence of a new pathotype of stripe rust in Lancer, okay? The thing is we have had pathotype changes differentially affect genes in varieties, and there's this sort of panic out there in industry that, well, I'm just going to spray everything because it could break down. Okay, Lancer has very durable resistance genes. Where we're seeing stripe rust in Lancer, well, I'll say with absolute confidence, if you've got significant stripe rust in your Lancer, you do not have Lancer. You have another variety. Okay, where we're having problems is where we've got off-types in it. So we've got a contaminant, generally got setting its heads a bit higher, so you haven't got this nice even crop, and they're the ones that are taking rust. So that's not Lancer breaking down, that's poor hygiene and a mix of another variety. And we do have what we suspect, and we're going to get some genetic testing done, some straight mix-up of varieties as well, where they think they're growing Lancer, but we suspect it's something else based on plant type. So, yeah, certainly hang in there on that. The number of calls about people spraying Lancer this year for stripe rust is, yeah, I think you need to freshen up your seed source if it's a significant problem. Okay, but Lancer can get seed infections. We haven't seen much of that at all this year because our epidemic is so much later, but it won't progress. So in seed infections, the stripe rust spreads sideways, up and down the leaf. It doesn't have the classic striping. It's only in the adult leaves where you get it confined between the veins and you get the stripe. Okay, if you're seeing it on higher leaves and you're getting classic striping, that's when we want samples because there could be a pathotype change, but we're not seeing that in any true Lancer. Photo just popped up now. This is probably the classic phone call I get 2 or 3 times a day at the moment is, you know, variety X is absolutely riddled with rust. My automatic reaction is send me a photo. You can see there, that is not riddled. That's APR taking out a small lesion. You got some flecking there. APR is well and truly working. It will not suddenly go yellow overnight when you've got those symptoms in your leaf. Adult plant resistance, the genetics is doing the job. So don't panic. Last one, support is available. So Brad and my mobile number there. Flick us some photos if you're worried. I think most people probably won't send us stuff because they want to spray anyway and they don't like being told not to. So I don't know who you're ringing in that situation. And please don't use artificial intelligence. We've had some absolute shockers this year where people put pictures they've taken into AI and it tells them all sorts of weird and wonderful things. I can't say Brad and I are that intelligent, but at least we've got some training and background. So hopefully keep us on track. Thank you very much. Oh, also huge thanks to those that use the service and help us with the all the agronomist growers with those random crop disease surveys. This gives us the industry intelligence. We can come and talk with confidence about what's going on across the region and what to do going forward. Now I can say thank you.
Fantastic. Thank you so much, Steve. That was excellent. I've just popped a short survey link in the chat box. So if everybody could jump on and provide us your feedback, that would be really helpful. But I just wanted to extend a huge thank you to Noel, Steve and Brad for today's webinar. We are right up against the hour, but I did just have one question. And maybe this is for Noel around rotating modes of action. And I just wondered if you could just clarify the point you were making around seed dressings and foliar sprays and how you need to be rotating modes of action. I don't know, Steve or Noel, somebody wants to
so
address
I
that
think
one?
that the point was that if you're using a group 7 as a seed dressing, you have to know what type of group 7, whether that's having a foliar activity, so moving up into the plant, or whether it's more focused on that seed and root region for controlling the, you know, which disease is it targeting and what part of the plant is it getting to, because that can affect where that influence is coming. But if anyone else has other descriptions around that, happy to.
Yep, all good. Excellent. Oh, sorry. No, we're all good. All right. As I mentioned, the AFREN website has a whole heap of resources available. So please head along to the website and check that out. But thank you again to Noel, Steve, and Brad and Fran for joining us today on this webinar. And we hope to see you again at another AFREN event very soon.